All right. Hello. Welcome
Hello.
to the lesson. All right. So I'm just
Hello.
gonna make a new. uh, Epic Games does. That's true. I'm just gonna make a new project for this. Just make a small little thing. Let's gonna start up the engine. How are you guys feeling about the project so far? It's going good. I'm seeing some great results, so I'm very proud. It's looking really good.
It's going quite well. We've figured out that Unreal's physics are, to nobody's surprise, weird.
Yeah, that's physics. Okay, so I'm just gonna make a new project here, C++, and call it Spline test.
You're recording your microphone as well, right?
Yeah, I am. Thank you for
Okay,
reminding
good.
me. He's waiting for the project to start. I wish I had something profound to say now, where it's like, I hope you learned during your time off that your lives are at stake, or something. I don't know, something profound. Does anyone else have anything profound to say?
Live and don't die, hopefully. Yeah.
Live and don't die. I think that's good. Good advice.
Live, love, lag.
Live, love, lie.
No, lag.
Oh, lag. I like the live, love, lie though. That's pretty good. Very manipulative. Have you guys warmed up to Unreal yet, or do you still feel it's shit engine worse than Unity?
I'm enjoying it. It's terrifying, but I'm enjoying it.
Quite okay, to be honest. I'm not sure I'm gonna make it all the way through that I thought, but I'm making progress.
That's
so,
okay.
Yeah.
Yeah, it's not about succeeding, it's about giving it a go. Now that's something profound. Now write that down in your fucking diary. Yeah, there. Always ready. All right. Okay. So what's a spline? So spline is a component. So it's not an actor apparently. I thought it was gonna be a spline actor, which was just gonna be an actor with a spline component on it. There's spline mesh, which is a different type of spline. It's kind of like what Freya did, where you can just draw out a spline and a mesh will sort of follow that spline. It's not exactly that. It's only 2 points, so you can only make one actor sort of, or one mesh bend between two Bezier points. And to make a complete spline mesh, you have to sort of chain these together. Maybe we'll can look at that at some time, maybe, but that's not the same thing. We want to look at just a pure spline. So I'm just gonna make an empty actor here, and then I will add a component, and I will add a spline. There we go. So it's a spline. And I'll actually make that the root component. So now we have an actor, and we can see the spline here. So it's just, right now it's just 2 points. It's just essentially a line. It's not very interesting. So I can click the points and drag them around like this. Oh, I actually dragged the anchor now. So now you can see there are control points, which are these two. Whoops. Actually, no, I think these are called spline points here. These are the spline points, and then you have the control points, which are these two. So I can click the control points and drag them around like this. If you ever worked with Bezier curves or anything like that, hopefully it doesn't seem too unfamiliar. So I can probably drag this guy, maybe drag this guy out a little bit. Drag this guy. What? Okay, I'll grab this one. There we go. So I can make like a little arc, or I can make like an S or something like that by controlling the control points here. So that's the basics of splines essentially. It's just points connected, and you control the curvature with the control points. And if I want to add more points, I can just let's say I want to go into local mode, so I switch it into local space for the gizmo. I can hold Alt and just drag, and now add another point to the spline. So I can continue doing this, and I'll add another point. So I'll just click the last point and Alt drag out. Oh, it actually inserted it there. That's not exactly what I wanted. Does it always insert? No, there we go. I guess it sort of checks whether it's closer to drag inward to drag outwards. I'm actually not sure how that happened, but just make it go up a little bit, and I'll drag the control point down like this, make it curve like a little mountain. I'll just like add one more. Whoop. No point. I can also insert points if I want to. So if let's say I want to split these two, right? So I have the beginning and I have the second point here. So I can just click in between, right click, and then just do add spline point here. And now I'll split those two up and add one more. So I'll just make that go up a little bit. Stuff like that. Not very controversial. It's quite, simple splining tools. So there we go. So now I made like a little spline. It looks very nice. It looks very neat. So something you very, very commonly do is have an actor maybe follow a spline. Let's say we have like a bird or like an NPC or something, and I want that NPC to walk along a spline. It might be a spline that's just sort of flat against the ground, or if it's a bird, it might go up and down or something. But that's a very common behavior to want to do. So let's make an actor that we want to follow this spline. We want to move along the spline. So I'll just make a C++ class. You can do this in Blueprint as well, it doesn't really matter, but since this is a C++ course, I'm thinking why not do it in C++. Of course, if it was just an actor following a spline, I probably would make it in Blueprint if this was like an actual project, until it grew big enough that it needed to be in code. But I'm thinking like it's easier to go from code to Blueprint than the other way around, so I'm thinking let's just do it the hard way. So I'll just do spline follower. There we go. And have you guys tried like dipping bread into a boy? It's the fucking best, dude. It's like happiness in like food form.
That does not sound
What?
good, but
What? I took like a
maybe.
tunnbrödsrulle and I just dipped it into a boy and I ate it, and it's so good. It's so juicy. It's amazing.
It's like, I get making like a boy's bread, but like dipping it in a boy.
Dude,
What?
you guys haven't lived. You guys are living too safe. You're too scared. So I'm just gonna make a property here. Unfortunately, so I want to reference this spline, right? So I want to place the actor in the world. So let's actually do that first, just to have that be done before we do anything else. So I'm just gonna pick the spline follower here, drag it out. Whoops, I don't have anything on it. Fuck it, I'll just add a root component in here. Whatever, it doesn't matter. Let's add a root component. I'll add a scene and I'll add a cube. There we go. So I have my spline follower here. Let's scale it down a little bit. And I want him to follow this spline, right? So for him to follow this spline, I need to reference the spline in code somehow. I need to get a reference to this spline. Unfortunately, like in Unity, you could probably do something like make a U property, make it edit instance only, and do something like, oh, I want to reference a spline component. So it's like target spline. I believe you can do this in Unity. So if I make this and I compile, oh, need to forward declare. There we go. There you can see it says none here. And I can't select anything. And I can't like eyedrop or in any way reference this component. And the problem with this is that you cannot set component references on other actors in the details panel. I don't know why exactly you can't do this, because you can in Unity. In Unity, if I had like I want to reference a spline component, I could drag any game object in there that had a spline component on it, and it will sort of get a reference to that spline component. I'm not sure why you can't do this in Unreal. Might be some technical problem or something. the way you have to handle it in Unreal is that you have to get the actor reference. So I have to reference the actor itself, and then on that actor actually get the spline component. It's a little bit dumb, but you know, whatever. So instead of use spline component target spline, I'm just gonna make it an actor pointer. So I'll do spline actor. I'll call it that. There we go. And I wonder if we can... Nah, never mind. Okay, whatever. So now I have an actor pointer as a U property. So let's see what happens now. So now here we have a little drop down, spline actor. So I can click the drop down and now I can select any actor in the scene. I can also use the eye drop here to just pick an actor. So I can just click the little drop symbol and you just click the spline and it will select that actor. So now I'm referencing this actor in the level. Very cool. So now on begin play, I can just get the spline component from that actor. So I can use in begin play, just do target spline is equal to spline actor, get find component by class. I used to use spline components. There we go. So now I'm just getting the spline component in begin play from that spline actor. Might do
What's the difference between get component and find component?
I have no clue.
Okay.
Let's check. Yeah. Seems like the get component is the blueprint version. So get component doesn't take a template, while find component does.
Oh, right. Okay, makes sense. Cool.
No clue. Cool. So now we have a target spline. So how do we follow it? Like, how do we go along it? Well, one way, there's plenty of ways, but one way that I will probably do is to keep track of the distance. So we will have some sort of variable in the spline follower of how far along the spline we should be. And then using that distance, we can sort of get on the spline what that transform would be at that distance. So then we can decide, I want to go 200 units per second or something. I would just increase the distance by 200 units per second and just keep getting the position on the spline. So let's try that. So I'm going to make a distance along spline variable. I'll set it to 0 by default. So then on tick, I'm just going to do distance along spline. Distance along spline. I'm just going to increase that by delta time. I just do 200 units per second. Sounds good to me. So we're gonna move 200 units. I guess the 200 distance. I guess it would be like the Unreal units. We're gonna move 200 units along the spline every second. And then we want to get what is a transform at that distance. So I'll do target spline. And then we just call get transform at distance along spline. So it's just a function. And then I'll just pass in distance along spline. So this function on the spline component, will give us what is the transform, that is like position and rotation, and also scale, but it's a bool, scale is skipped by default, which is kind of nice. At whatever distance along the spline, and we're passing in this float that we have. And then we also need to provide what's coordinate space to get that transform in, because we might want to be attached to the spline, in which case we kind of want to get it in local space, or we could get it in world space. So local space will be like from the spline components relative space, what is the transform, and world space will just be like, okay, in world space, what is the transform? In our case, we don't want to be attached, I'm just going to world. 95%, that's the one you're going to use anyways. So I'm just going to do that. So what we're doing now is that we're getting a spline, getting the transform at some distance, and that's going to be this distance along spline that we're increasing by 200 every second. And we're gonna get a transform in world space. I'm just gonna save that. F transform. Spline. Transform. Like so. And then I'm just gonna do set act to transform. To be the spline transform. Easy peasy, and then we also need to include it. There we go. Let's see what happens. Alright. So, I'm gonna simulate here. Let's see. Amazing! It just follows the spline. I'm gonna actually reset the scale and just make the cube smaller.
Quick question.
Yeah.
Can you connect the spline so it's possible for the actor to go through the entire path and loop it?
Yes, that's a really good question. So right now it goes and goes and goes and goes, and then it stops at the end. So the question was, can we loop the spline? So we can sort of make this end point be at the start point, and then you keep going around. Well, yes, you can, and it's very easy. You just click the spline component, and you just do closed loop. So here's a bool, you just check that, and now the spline is a closed loop. So the last point will be connected to the first point. So now when I play, it goes, and he kind of stops there anyways, because we're trying to get a distance. Like as I said before, our distance is just increasing all the time, and we're trying to get a transform at a distance that's longer than what the spline is, and it doesn't automatically sort of wrap it around to me like, oh, your distance is bigger. Then I'll just subtract the length to get like what on the spline length actually what you want to do. We have to do that ourselves. So I'm just gonna do if distance along spline is bigger than target spline gets spline length. So if our distance is bigger than the length of the spline, I'm just gonna subtract the spline length. There we go. So it's gonna loop around. So as soon as I go above the spline length, I take away the spline length. So I will be remaining. The remaining in the distance will just be how much I overshot the spline length. So now if I compile this and see what happens, he should be going around and around in a circle. Stop and play. There he goes. And there you go. So you skip through and then it keeps going. So we're going around in a circle forever. And that's the basics of splines. That's, the most basic behavior ever. Any questions on this? I can of course change this in runtime as well to change the path if I want to. Make this
If
low.
you wanted to spin the thing as it moves, is there a way where you can like define what transform you get back basically?
Yeah, of course. So you can do like, so let's just do it easily. Let's do a static float, rotation. So then we can just do like spline transform, set rotation, and we can do spline transform, get rotation times f quad. So I want to make it spin around on the Z axis. So I'll just do like an angle axis around the up vector. And I'll spin around with rotation angles. There we go. So I'm taking this spline transform's rotation and multiplying it by an angle axis. So this default constructor, as you can see here, is axis and angle rad. So angle radius, or radians, sorry. This is an angle axis constructor for the quaternion. So I'm just giving it spin around the up vector with rotation angle. So let's make the rotation plus equals Of course, never make a static float. I'm just doing it to show that it will work. So now, do you know what static variables in functions do, by the way?
Yeah, we did that, right, guys?
That you only can have one instance, right?
Yeah, so this will be a global function or global variable just contained inside of this function. So now we can see. Oh, it's kind of hard to see, but you can see that he's sort of spinning around on his top axis as well. It's a little bit chaotic. You can kind of see it.
Is it possible for actor to switch from one spline to another?
Yeah, sure. So we can do 2 splines.
Can I just ask something about the rotation while we're still at that?
Yeah, of course.
Could you rotate the points in the spline, and would it follow that by default, like the rotation of that?
Well, so you can't directly, like if I click a point and rotate it, all I'm doing is sort of rotating the control points like this.
Yeah, but if you do that on like another axis, like.
Oh yeah, you can roll them as well. So you can show actually if I do draw.
Is that where it says default up vector? Is that where you would set inside
Right.
the spline drop down? Is that how you would do what he's asking?
Probably.
Yeah.
Yes. But that would be for all points, though, right?
Would it? Oh, mate.
Well, that's just when you create a new point. It will set this as the default.
Okay.
But you're supposed to be able to. Fuck. How do you set? You're supposed to be able to debug, so you get like a plane almost. Dang it! But I don't remember. It's supposed to be this draw debug. Maybe if I scale it up, let's scale it. Ah! Okay, so scaling it doesn't work. Scaling it will just scale the control points as well. Actually, that's only the Y scale. You can actually scale it. As you can see here, the scale is changing on the point. So you can like query what the scale of a spline is. If I do... this is a little bit more advanced. You don't use this very often, but you can do get scale at distance along spline. So that will give you what the scale of that particular point is. It's mostly used for stuff like, okay, in It Takes Two, for example, we had like fishes swimming around following splines. And then the scale control how fast they will move through that particular point. So let's say we want to be like, okay, I want you to go fast here, but slow here. Then we could use the scale of the spline point to define how fast the fish were supposed to be moving at that particular point. But it doesn't have any functionality onto itself. It's sort of like what you decide the scale to mean. Yeah, but
That's really clever. Yeah, I'd never thought of using that to control
Oh,
speed. That's really smart.
Okay, so here we go. So now if you click this scale visualization width, then you can see that the points are not just a line, it's sort of like a plane, right? You can see here's the plane at that particular point. So now if I roll this, you can actually see that the plane is rolling. So now if I move here, you're gonna see that the guy is sort of rolling. Okay, it's kind of hard to see because it's so chaotic with the spinning and everything, but he is gonna roll 90 degrees here and then sort of tilt up slowly as it goes past.
Cool.
It's kind of
And
chaotic though, like using this, like you can see that the planes sort of behave a bit weirdly. Like here you get like a sharp dip into it. Whoa. And apparently that's a thing. Oh, I think it's because
the scale, right?
Yeah, it's the scale, exactly. So I'm just gonna reset the scaling here. There we go.
But it seems like a fun way to do Roller Coaster Tycoon.
Yeah. Yeah, so splines are very useful in that case, and you can see here that it didn't really work, but yeah. It's a rough approximation.
So how do you make so you could switch between different splines?
Right. So if we want to switch between splines, let's just add another one, I guess. So in that case, let's maybe do so we have an array of actors. So I'll do an array of spline actors. And then also I'll do an array of spline components. Oh no, wait, it's not an array pointer. It's supposed to be a pointer to, or an array of actor pointers. There we go. And then instead of setting 1, I'm just gonna loop through them. So I'm just gonna do auto actor in spline actors. I will target spline. I'll make them plural actors and splines. I will add to the splines. There we go. So I'm just looping through all of the actors and getting all of their spline components. And then adding that to this target splines list. So then we can perhaps do like, okay, which index in this array are we supposed to be following? So just do like a target index equal to 0. So we're gonna follow target index 0. So then in tick, I will just get that. So I'll just get the, whoops, get the target spline is gonna be target splines at target index. So if it's 0, we're gonna be following the first target spline, or the first spline. Does kind of make sense what I just did? It went a little bit fast, but hopefully it made a little bit of sense. So now in this actor, if I compile first, there we go. Instead of having one reference, we now have an array in here. So I can add, and now I can add as many references as I want. So I'll add this one, and then I add another one, and set that reference as second spline. So now I have an array of actors instead of just one. So if I play, okay, since we set the target spline index to be 0, he's always gonna be following this one. So let's say we want him to switch every 5 seconds, let's say that. We'll just do like target index, we'll do, let's do a timer, I guess. So target, switch, timer, is equal to 0. We'll just do like target, switch, timer, plus equals delta time. And then if target switch timer is more than 5, hard coded, but that's the way I roll, baby. I will do target index plus plus. Right?
No, you have to mod that, or you're gonna
Yeah, I'm gonna be
rate sure.
I'm gonna be sad. So I'm just gonna mod this. So I'll do target index plus 1 mod target splines num. There we go. So now he's gonna switch back and forth between the two splines. So he's gonna be spend 5 seconds here, and then what did I do wrong?
Reset the timer.
Yeah, there we go. So I'll use the target switch timer is 0. I could also do minus equals 5, but whatever. Do I look like a nerd? Okay, so now so he's gonna spend 5 seconds going around here. And then, boom, he jumps to that spline. Hooray, we made AI, right? Looks very good, I think. And I can switch this one around. Okay, so the thing is that this is the most absolute basic way of doing spline following. Sometimes it's useful, but as you can see, it doesn't really look very natural. especially if you use multiple splines. It's not a very nice like snap to one or the other. So if I made a spline following system in like an actual game, I probably wouldn't code it exactly like this. I would use like, it would be inspired by this, but it would be a little bit more sophisticated. So I thought we would just do one way of making a little bit more sophisticated movement that will also show off another feature that's very good with splines. So, what the fuck did I do? I think I removed the ground. Yes, I did. So, this is what we're gonna do. We have our spline. And we have our actor. And I'm gonna say, okay, this is gonna be like, again, a bird or an NPC or something. I wanted to move around this spline. So instead of having him like snap and then he's like go at a very fixed speed, I'm instead gonna say, okay, move towards the closest point on this spline. So wherever you are, if you're outside of the spline, that's fine. Like you maybe bumped off where the player interacts with you or something. That's fine. Just move to the closest point on the spline. So I'm gonna say, okay, pick whatever point is the closest and then move towards there with some sort of fixed speed, like at your movement speed. So then if for whatever reason we switch spline or he gets moved off or something or the spline moves, that's fine. He can sort of auto-correct to move to the spline. So how would we do that? Well, there's a very nice feature. In target spline, there is a find location closest to world location on the spline. So this will take some world location and return you which is the closest location on the spline to that world location. So that's what that does. And it will return you, in this case, this point here. Because that's the one that's closest to this world location. So we're going to feed in our get actor location. And we again have to do coordinate space. So, but again, I will just do it in world space. So now instead of a distance, we're working with where I am and how do I get to the spline. So we have sort of a target location. So I'm just going to do a target location. And then I'm going to move towards that target. So I'm just going to do target location. Or I'll do target direction. It's equal to target location minus get actor location. So I'm just getting the direction to that target. And let me just do get safe normal. So we have a normalized direction to get to the closest position on the spline. And then after doing this, setting the actor transform to be on the spline, I'm just gonna comment this out for a sec. Instead, I'm gonna just move in that direction. So I'm just gonna do add actor world offset. Target direction times 200. So I'm still gonna move at 200 speed, but just towards it times delta time. Okay. Does this make sense? Can anyone predict what's gonna happen?
You're gonna move towards it, and then you're gonna overshoot, turn around, and overshoot and turn around for infinity.
It's not gonna look nice, I'll tell you that. But it's the first step. So let's see. We have the guy here, right? So he's not on the spline to start with. I'm actually gonna move him a little bit further away. He's not on the spline to start with, so hopefully, if our theory is correct, he's gonna move towards it. So let's play. Yeah, there we go. So he does move, and after 5 seconds, he's gonna switch spline and move to the closest point on that spline. and then it's gonna move to the closest point back here. Then after a second, it's gonna move back here. So, okay, it looks a little bit better. Like, okay, we don't have the snapping now, which is nice. But, I mean, it's not perfect because, I mean, we lost the whole functionality of actually going around the goddamn spline. So, I'm actually gonna combine the two things we've done now. We have distance, we have finding the closest world location, and I'm gonna combine those two concepts in a way to get sort of a nice moving behavior. So instead of getting the world location of the closest point, I'm instead gonna get the distance along the spline to that point. Okay? So let's say the starting point is here. Like this is the start of the spline and also end of the spline. And I want to get, okay, here's the world location here that I want to get the closest point to. But instead of giving me just the world location of that point, give me the distance along the spline to that point. So we'll give this distance here. So it might be, I don't know, 800 or something. Because then what I can do, I can do something smart. I can offset that distance forward. And say like, okay, take that distance, but take it 200 units forward. Or whatever arbitrary value. And then I'm going to say, I'm going to move towards that point instead. So that means I'm going to sort of predict forwards where I'm supposed to be moving. So he will move sort of like with an arc like this. So he will move forwards like this. But then as he's getting closer, this point is also moving away, right? Because as I'm moving closer, the closest point will move in, which will make the offset even greater. So I'm moving in, I'm here. The closest point is here. Offset 200 units is going to be here. So he's going to keep moving and then eventually converge on the spline like this.
Wouldn't he also eventually start cutting corners?
Yes, so he will start cutting corners because he will sort of predict a turn, right? So if I go back, so like if he's here, right, if the position is here. So if he's exactly on the spline, that means the closest world location is going to be here, or the closest position on the spline is going to be on the same point. But then when we offset 200 units forward, it's going to be, you know, after the turn, something like here. So that means he's going to cut the corner and it's going to move in that direction. Which is, you know, we can alleviate this, of course, by making the prediction smaller. So we can say the offset is just 550 units or something. We could
say that the offset is dependent on how far away from the spline point he is. We're already calculating that anyway, so...
We could do that as well. We can do a lot of magic to get this to work. Usually it's not a problem, though. Usually like this works good enough for movement to look smooth and nice. And also it looks a little bit more natural. That if you have a spline that looks kind of wonky, like it has like a turn like this, or maybe a sharp corner even like this, then it kind of looks nicer anyways, that it sort of gets like rounded out a little bit. That the person sort of, you know, it cuts the corner, it looks natural. It looks sort of what an AI would do. So even though it's like, okay, maybe that's not pure and perfect, but I mean, it's kind of nice. But yeah, it can be alleviated by doing stuff like predicting and making the prediction smaller, or, you know, doing distance-based prediction and so on. So it can definitely be alleviated.
Shouldn't we be able to like take delta time into account with the prediction?
Yeah, you can take delta time as well. I mean, in that case, you could probably just do like, if the distance is less than whatever, then just do the distance thing we did before. You could probably do that as well, if you want to do. So yeah, it's not really a problem. That's hard to solve. But either way, let's get that going. And for the first step, we need to get the distance. So instead of getting the location that's closest to this world location, we want to get the distance. And unfortunately, for some reason, I don't know why Unreal decided to do this, there is no function called just find distance closest to world location. We have it at Haze, we just like coded it in, because it's such a useful function. But for some reason it doesn't exist. So there is no find distance. Yeah, closest. However, there is find key, input key closest to world location. And that's kind of the same thing. The difference between input key and distance is that input key is simply 0 at the first point, and then it's sort of a lerp in between key 0 and key 1. So like 0.5 of input key would be just halfway between point 0 and point 1, and 1.5 would be between 1 and 2. So, you know, it's sort of the lerped value on the spline, which kind of helps, kind of doesn't, but that's at least the first step. It's kind of something. So I'm going to start by getting that. So we're going to find the input key closest to world location, and it's going to be get actor location. And we don't have to specify any space, because of course key doesn't change if it's in world space or local space. It has nothing to do with that. It's just sort of where on the spline you are. So I'm gonna save that as input key. And then here's the second step. We can, from the input key, get what distance is. So I'm just gonna do float distance is equal to target spline get distance along spline at spline input key. So there's a function to convert from an input key to a distance. I have no idea why this, you can't just do a helper function to do these 2 steps. To just do like find distance along, that's what we did at Hazelight. I was surprised that wasn't in vanilla, but either way, it doesn't matter. So I'm just gonna send in an input key there. So now we went from a world location to the closest key, and then we went from the key to the distance. So this distance is gonna give us this this distance here, right? Along the spline from the start to the closest point to our world location. So now we have that. And now I can add this offset. So I'm gonna offset it by, I don't know. Let's offset it by 10. Let's do 50. So we can do quite a small offset, doesn't really matter. Cool.
Forget plus equals.
Sorry, what do you say?
I don't forget like plus equals for offsets, because now you're setting it to 50.
Oh, whoops. You're very quiet, by the way. I think your microphone is not like turned down or something. Yeah, so now we're increasing this distance, the distance. So now we can get the target location by getting the location at that distance. So I'm gonna do get location at distance along spline. So now we're finding the target location by getting what is the location of that distance that we offset forward 50 units. Then we're getting the target direction. Whoops. Then we're getting the target direction, and then we're moving. So let's see. So now hopefully he should be moving towards the spline, and then you sort of walk into a path into it. And then as he switches, he should start moving towards the other one and then ease into a path. Whoops. Ease into moving along that as well. So that's it. Let's play. So there he goes, and now he's going along the spline. And you can see that he's sort of cutting corners and so on. Like you see, he didn't actually touch this spline point here. But he is very nicely sort of moving from spline to spline. No problem at all. And it's very nicely following them. And, you know, I can move the spline. So if I move this, then it will just like he will just go back into orbit very nicely. He will just keep finding the closest point and you know, continue the looping from there. So it's very modular and it's very hard to break. Like it sort of looks good no matter what I do to the spline. I can rotate it as well, and it still works just fine. And if we wanted this to look even more natural, we can of course use velocities instead. So like this, he doesn't just add active roll offset, he just, has a velocity and he accelerates towards the spline instead. So then it will be like a car going around a track or something. Or a bird, as I said, like I want this bird to follow this spline. Birds don't really turn on a dime like he does here, right? Like when he switches to the other spline, he goes sort of like, bah! Like turns on a dime, 90-degree angle, goes to the other one. Like that would look really weird for a bird. So then I would just do it so the bird is controlled with velocities and forces, and he's just sort of applying forces in the direction of the spline towards the target location. So then it will look more natural when it switches. Super useful. I can't stress this enough how often this is used. It is used absolutely everywhere. Systems like this, exactly like this. I've sort of like written the bread and butter formula for how we do like almost everything in the game. Like if I just open up like the gameplay trailer for It Takes Two, I can probably just point out a bunch of places. Like this is splines. This is a spline. I don't know about this. I haven't worked at this, but yeah, he's a spline. No, it's not. That was just a joke. She's a spline. No. Oh, come on. So much story. I don't care about story. I want to see gameplay.
Spoilers.
Like these guys, when you like pull them out or when the fuse blows, like these guys will run away and they're running on a spline. These guys are probably floating up and down on a spline. This whole area here is a spline. Also, when you're fighting on the roof, there's a spline on the roof that the guys are following. These guys, this tree trunk here is a spline. Yeah, squirrels, they're pretty cool. These movements, that's splines. These guys are moving along splines here. It's a fucking sap gun. I don't think these guys are actually moving on splines. I don't know, I think their exits from the hole is a spline. I'm actually not super sure, but these guys, the way these guys moves in, splines. And so on. Like, it's everywhere in the game. Because it gives you such fine control over nice movement like this. The way she's locked here, you see this 2D movement, that's a spline. That's a curved spline around this area that the character gets locked to, and so on. It's everywhere. So that's why I wanted to like really make sure that this is important knowledge, because it's such a powerful tool. That, you know, like here it's splines everywhere. Like if you open this up in the editor, there's like splines like literally fucking everywhere, because there's guys moving around and they are following splines and switching splines and branching splines and so on. So it's like, it's insane. And of course all of the like the little lamps here, they are also splines. So yeah, I don't think I need to stress this more than that. Very important thing to learn because it's so powerful and so nice. But yeah.
So, Chris, begin play, is it one when the game starts or when the object it attached to is spawned in the game?
When it's spawned, kind of. Yeah, it's sort of like awake in Unity. So if it's in the level, then it's when the game starts, or if it's spawned, then it's when it spawns. All right. Any questions?
One question about the application of splines.
Mm-hmm.
If I were making, say, a City Skylines-esque city builder, I would probably want to use splines for my road network, so for all the different lanes and stuff, instead of trying to have the engines actually figure out, oh, I have to move here, I have to move there, for example, right?
Yeah, I'll probably use splines there, yeah. runtime splines are a little bit shaky. Like changing splines in runtime, that's pretty expensive. But still, I would probably use splines in that case, yeah, or some mathematical version of them at least. All right, cool. I'll still be around. So, if you come up with more questions about splines or anything, then, just hit me up on Discord. I'll be in the channel. So just join in. But otherwise, that was just a short little mini lesson about this wonderful tool in Unreal. Mostly, I didn't want you guys to get scared when you saw that the designers were absolutely obsessed with this, because they are. But it's for good reason, because they're very good. So, I want you guys to be ready for that. Cool. All right, so just keep on working with your projects, and I'll be in the room. Hit me up when you have any questions, and then on Friday, we'll do a little lesson about AngelScript. So that won't be anything that you might need to remember anything. You sort of like on request, and it's, I think it's such a wonderful thing that I kind of just want to share the love about AngelScript, because I think it's so cool and so fucking good. Like, it makes Unreal 80% more bearable. So I was thinking that maybe you would appreciate it. So we're gonna do a short demo on AngelScript and then show you some stuff and so on. But otherwise, just keep on working with your stuff. It's looking really good. So yeah. Any last words before I end your life? Before I strike you down?
Break
If you
our
strike the lava, will
spines.
you become
Yeah.
even more powerful?
Just pick up and like.
Did you say break our splines, Willem?
Pick up. Yeah, exactly.
No questions on this in particular right now.
Cool. All right, then see you later. Bye. I'll upload this to YouTube. Bye.
Bye.
That's just you and me, baby. Hope you had a good day. Love you.